Okay, welcome to homework 1, and here I will give you a recitation to help you get started. The first part of the recitation is some useful data structures in your base code, and then I will talk through our base code workflow, and finally I will introduce some extra things you can do to make your rigid body simulation better. In rigid body class, there are state variables and material variables. You should be very familiar with the state variables when you are trying to resolve contact or collision. And the rigid body class have three subclasses: the sphere, cube, and ground. And these are the objects you can see in your world scene. And there are a lot of useful methods in the rigid body class. You'd better take a look at the head file, and there are instructions for useful functions, and make a good use of them can save you a lot of time. For example, for the inertial tensor, you can use the first function to get the normalized local inertial tensor and use the second function to get the inertial tensor in local space and use the third function to get the inertial tensor in world space. And in the intersection struct, there are several key members. The body A is the body that you are working on, and the body B is the body that body A penetrates into. And there are 3 points in 3 different spaces: the world space, body A space, and body B space. And also the out vector is the vector of restitution for body A in world space. And here is a picture about the intersection situation. It's pretty intuitive. And there are several key methods in this struct. There are 3 methods that are given to you, and the other 3 is the methods that you need to implement. You have to implement the box-ground intersection, ground-sphere intersection, and sphere-sphere intersection. And in world class, the m-bodies is a vector that stores all the rigid bodies in the world, and the key methods is something that in our main workflow, and I will talk about that later. And the XM world visitor is the class that can help you load your world file. Okay, and in our main simulation loop, your main task is to resolve collisions and contacts. There is a difference between collision and contact. To resolve collision, you have to reflect the velocity using the coefficient of restitution, and to resolve contact, you have to cancel the normal direction velocity when 2 objects are stacking. And the 2 pictures below shows the difference of the velocity change. And whether interaction is collision or contact is determined by the coefficient of restitution. When the coefficient of restitution is 1, the interaction is counted as collision, and when the coefficient is -1, it counts as contact. To resolve collision, you have to keep in mind that to resolve the interaction and include impulses with positive coefficients. And to a dense velocity, it's pretty easy. Just keep in mind you have to include all extra forces. And to resolve contact, the difference is you have to resolve the interaction and apply impulses with negative coefficients of restitution. And the resolve context is always used for stacking objects. Advanced position is very easy. Just update the position and orientation using current velocity and angular velocity. Let's look back at our main workflow. There are two parts we haven't talked about. First one is resolve interaction, and the second one is find intersection. To resolve intersection, you have to implement the function in word class. And there are more details about how to solve this problem in the rigid body simulation paper. And the resolve intersection is the most important part in rigid body simulation that worth 30 points in our homework 1. And find the intersection. In this function, the brute force algorithm is given, but it's just for you to test other part of your code. You're not supposed to use brute force algorithm when you're submitting your code. And there are many other algorithms like octree, KD tree that can speed it up. To make your simulation more efficient, the find intersection is the best part you should be working on, and you can get extra if you make it fast enough. And if you want to work in game industries, they are crazy about performance. There are some extra things you can do to make your simulation better. The first one is you can make it more stable. Refer to the section 8.2 of the stacking paper. You can get more details about how to solve the stacking problem. Also, interesting things is always good for demo reel. And take one step further, you can render your simulation in Maya. There is a tutorial about how to import the jelly cube simulation into Maya, and this one can use the same methods. And if you have good rendering or good tutorials about how to rendering the rigid body simulation in Maya, you can get extra credits for it. And to start your homework, there are 7 places you need to fill in the base code. They are marked as to do. And before you start filling code, you should take a good look at the place that marked as look. This can give you a better understanding about how the base code works. Here is our recitation. Hope you have an idea about how to start your first homework, and good luck.